From version 2.408, Process Simulate provides full support for Delta robots. So you can simulate and validate Delta robot workflows effortlessly. In this demo, we'll explore a simple use case to showcase Delta robot capabilities. Let's load a Delta robot from the asset library. We can filter the asset library to display only Delta robots. If you want, view details of the selected Delta robot to confirm it is the right one. Drag the robot into the study. Delta robots have 3 lightweight arms connected to a fixed base in a triangular Delta layout. The arm motors are mounted on the robot base. The additional central arm rotates the mounted tool. We have used the Mount Tool command to mount the suction gripper on the robot tool frame. Let's open the Robot Jog dialog box. We can now jog the robot TCPF using the placement manipulator in the graphics. Or adjust any of the robot joint values from the Robot Jog dialog box. When jogging Delta robots, unlike articulated robots, Process Simulate has to recalculate values for all the robot joints. Select the robot and let's create a bin picking operation. The robot will pick up each part from the part tray and place it in an empty slot on the part rack. Select the bin, in this case the part tray. Drag your mouse to specify the parts or select them in the object tree. Click OK to generate the new operation. The new operation is displayed in the operation tree. Let's load it in the path editor. The new operation consists of all the pick locations for the parts. Now let's use the Apply Path Template dialog box to create approach and depart locations for all the locations in the bin picking operation. The bin picking operation now resembles a pick and place operation. When we run the bin picking operation, the robot picks up the parts and places them in racks. However, the robot has failed to place the last part and the simulation has terminated. The robot has picked up the last part but is unable to place it, and the last slot remains empty. We'll access the simulation monitor to understand what has happened. Here is the reason. The robot cannot reach the location of the slot for the last part. We have prepared a reach envelope, shown by this pale blue cylinder-like volume. This volume encompasses all the points that are within the robot's reach. You can clearly see that the slot for the last part is outside this envelope. And therefore the robot cannot reach it. The simple solution is to select the robot and use the placement manipulator to move the robot together with its reach volume a few millimeters to the left. The slot for the last part is now inside the envelope. The robot can reach the slot location. Let's run the bin picking operation again. The robot completes the entire operation successfully. Let's run the sequence in the context of the workstation in line simulation mode to verify the behavior. Let's show you some information about the reach envelope. Select the robot and launch the kinematics editor. Double-click the platform Z-joint. The Joint Properties dialog box opens. Click the Fixed Joint Properties icon. The Variable Joint Values dialog box opens. This describes the extremities of the reach envelope. In other words, the furthest points the robot can reach. Let's display the reach envelope above this graph. Note the graph displays 1/2 of the reach envelope because the envelope is defined by its radius. The origin of the graph corresponds to the robot's tool frame. The first corner of the reach envelope is at x equals 0, y equals 45. The next one is at 565.45. And so on. And back to 0.45 to close the envelope. This is the radius of the cylindrical reach envelope, and this is its height. In this demo we have shown Delta robots are now fully supported in Process Simulate. Configure and simulate Delta workflows using familiar tools. Automate part handling with bin picking operations. Optimize motion using Apply Path Template to create pick and place flows. Validate reachability with predefined reach envelope visualization.